Great, is my screen being shared appropriately? Yeah, okay, fantastic. So Phil, that was a great introduction to so many different topics regarding the metaverse. What I'm gonna concentrate on in this talk is what I'll call the open metaverse. So Phil mentioned a variety of situations where we have proprietary metaverses. He mentioned Second Life, Fortnite, Roblox, Minecraft, and without a doubt, there are going to be many metaverses in the future, and a lot of them are going to connect together. But without a doubt, there's going to be at least one open metaverse based on open standards where everything can talk to everything else. And it's that open metaverse that I'm really going to be focusing on in this talk. So, we've all seen it. Philip's given a great introduction. There are all kinds of different applications. There are things that we already have that we've experienced. And there's a huge amount of momentum towards metaverses for all kinds of purposes, for social purposes, for gaming purposes, but also for getting real work done. And as it impacts the computer vision community, not only are there the questions that Philip raised of, how computer vision technology can enable a better experience for somebody who's in a metaverse, but also the set of opportunities for computer vision technologies to be trained in the metaverse. We have a lot of efforts going on throughout the industry in synthetic data generation. If you can build the data synthetically, you can train these computer vision models in a way where the absolute ground truth. You don't need people to go ahead and label it for you. So the implications for computer vision are very wide. As I said, we believe that the world needs and is going to have at least one open metaverse. And the question is, how do we get there, and what does it look like? So I'm going to make the claim that the true metaverse, the open metaverse, is really like a 3D web. It's a set of common interchange formats, protocols that allow everything to talk to each other. The way the 2D web is built out of all kinds of services and protocols that all connect together. And what do we need to do to build this? I'll say that at its center, we need an open, powerful 3D scene description. We need to be able to create these standards for things to connect all together and do what's necessary to accelerate the adoption. Well, we have this great 2D web. People have been using it for years. And a lot of people said, hey, why don't we just add 3D to it? And there've been a large number of efforts, starting way back in 1994 with Vermal. We've got X3D, we've got GLTF, WebXR, WebGPU, et cetera, et cetera. We actually think this is a great effort. It's part of the solution. But in order to get where we really want to get with an open metaverse, we have to go a different direction. We have to ask, what do we need for 3D, and how can we embed 2D inside of 3D? 3D is just fundamentally a much more difficult problem. And to stuff 3D into 2D is really the tail wagging the dog. So our suggestion is to take a very different approach and do 4 things that are different from what people have traditionally been doing. So first of all, at its core, let's start with the right 3D representation. And that means, no, not HTML. HTML was never designed as a way to represent 3D. It has a very large number of failings. Its biggest failing is that it's not incremental. So if I send you a 2D web page out of HTML, and then I want to change it in some way, I essentially have to resend it from scratch. That works in the 2D web because most of the pages that we're interested in are just not that complicated. I can resend the whole page in a very short amount of time. But if we're talking about building an open metaverse, we're wanting to share hundreds of megabytes, gigabytes of data, and we can't resend it every time it changes. So whatever it is that's going to serve the same role as HTML in an open metaverse, it must be incremental. Now, web standards organizations traditionally have wanted to make sure that everybody can see the same thing. Early in the web, we had a lot of different devices with a lot of different capabilities. Some of them weren't able to do everything that we wanted. And so we accepted the idea that web pages would look very different on different devices. But today, the web standards committees have taken the approach that, hey, we have enough compute power. We can really make everything look basically the same with a slight dichotomy between desktop and mobile. And the approach has then been, as you extend this to 3D, now you're using a least common denominator point of view. And we don't think you're ever going to really get to the proper destination if you insist that every metaverse connected application is going to have to run natively on the least capable, on the smallest device possible. So our approach here is to really emphasize the ability to access this from everywhere, but to rely as much as possible on streaming from more capable devices when you're looking at very small devices for the end user, like phones, or perhaps some of the AR devices that are on your head. In the next direction, we think it's pretty important to look at things a bit differently than people have, is to support authoring at all times. So we don't want to insist on a kind of a baking process that would reduce things into a situation where only pre-scripted possibilities are supported. So think more like Minecraft and Roblox, rather than the traditional experiences supported by game engines. Well, how are we going to get there? As I mentioned before, at the center, we need a representation that's open and very capable, that can describe virtual worlds with the richness that we need for the full variety of experiences that we want in the metaverse. We believe that USD is the right answer here. Universal Scene Description, it was open sourced by Pixar. It was developed at Pixar literally over decades to support the needs of their film production. And they've done this community a tremendous service by building this thing based at its center on just keys and values, but built on top of that a set of schemas that are capable of describing basically everything that you want in a virtual world sufficient for a Pixar film. Fortunately, it's also extensible, and we have been working very hard with a lot of different industry partners to create new schemas to extend the range of applicability as far as possible. And we really believe that it represents the proper sort of HTML analog for the 3D web. It comes out of the box with properties like lazy loading, the ability to represent things differently with variants. Most importantly, it comes with the ability to do layering. If you haven't looked into USD in detail, I really suggest that you do. The layering is in some ways reminiscent of what Photoshop does. And the idea is that you have these properties and values, and each layer has a strength. The layers are combined from weakest to strongest. And the strongest ones can override any opinion, any value associated with any of these keys. And so it allows, first of all, a collection of people to work independently on separate layers. And it also allows somebody to publish an asset that's read-only. That asset itself can't be changed, but additional layers can be added on to customize that in any way that's appropriate or necessary. So USD, as I said, out of the box, it comes with a tremendous amount of value, expressibility from Pixar. But there are some gaps, and we've been working as hard as we can to try to fill in some of those gaps. One of the gaps is that it wasn't initially designed for true interactive experiences. It scales very nicely to very complex environments, but fast updates have not been a strength of USD. And we've been building a lot of infrastructure around USD to support that. And now we can do hard real-time simulation using USD for our drive simulators. So we actually can put our autonomous driving brains inside of a live VR sort of environment where we simulate their sensors, feed them in, and so they can go ahead and prove their safety in simulation rather than on the road and potentially doing harm to some people. We've worked hard to extend the material capabilities of USD. So we've open sourced MDL, material definition language, and created a way to represent that inside of USD, allowing very high quality materials. We've also been building proceduralism into USD, something we call OmniGraph, which I probably won't have time to go into in any depth. We've open sourced our PhysX simulator and also done an integration with USD. Well, how can you take this and bring it into this notion of an open metaverse? We've built a platform, Omniverse, based on this principle. And what we have at its center is a database to represent a shared understanding of a scene. That database is expressed in USD. It's built out of pieces. The pieces are the layers of the USD that represent the entire scene. And those pieces are distributed through a pub-sub mechanism. And the pub-sub mechanism for each layer is incremental. So we've taken USD, we've built an incremental library on top of it. So essentially you use the USD API to do anything that you want to do to change a scene. You can create new objects, you can alter their properties, you can move them around, and you publish that result to the central server we call the nucleus server. And then that is then sent along to all the subscribers. The subscribers can be either applications that you use to interact with this virtual world. They can be technologies that create behavior in this virtual world, or they can be ways of viewing it. They can be desktop renderers, they can be AR renderers, they can be VR devices. Any of these are all supported. Let me show you that we built this for ourselves for a variety of purposes, to connect up our teams, to make it possible for us to do development together very effectively, to build complex virtual worlds for applications like driving. And we believe strongly that the metaverse is much more than social. We're looking at applications in architecture, engineering, construction, obviously media entertainment, games, product design, scientific visualization, robotics, and of course, autonomous driving, as I've mentioned before. So how does this work in a little bit more detail? I mentioned the nucleus server. We have connected up to it a wide variety of some of the most popular content creation tools. Everything from Maya, 3D Studio Max, Blender, Unreal, Revit, Adobe Substance, SketchUp, on and on and on and on, adding more all the time. We've created an open library where people can integrate USD into their applications, talk to our Nucleus server, and then automatically be able to communicate across all these applications in a way that we sometimes describe as Google Docs for 3D. People can access this, get a window into this world, and modify and experience it from any of these applications, from custom new applications, and then view them through workstations, VR, AR, even web browsers. How does it work? Essentially, we have, we can take a legacy application, we can introduce a plugin. The plugin has a copy of the USD library. Normally when people say they push buttons on the application, that causes a notification. The plugin realizes that something changed. It makes the corresponding change to the USD library that has happened in the internal scene graph of the application. And then through our Omniverse Connect library, that is then published to the Nucleus server, and then from there to every other connected client application. So here you can see an example where we have 3 applications on the left, all being used live. We have Unreal, we have Maya, we have Substance in the middle on the left. And on the right, we have Omniverse Create, which is now doing live path tracing of the shared result. So people can subscribe to either the full asset or portions of any part of the asset and get live updates across any of these applications. Our vision for Omniverse is built up of these 5 different pillars. We have the Nucleus server at the center, which is the analog of the HTTP server and the traditional web. We have a library to connect up new applications. We have a toolkit to build on it. We have a set of simulation technologies, which are some of them open source, and connections to other simulation capabilities. And then we have the RTX renderer, which enables the highest quality visualization. We believe firmly that a real 3D web, the ultimate metaverse that we want, should be something you can experience from all the available different devices. Highest quality, perhaps, on traditional screens, but then mobile and XR devices. So I'll show you a little bit about how these can access the same database. Here we have somebody making use of Omniverse. We have live capture, computer vision, pose recognition. That's publishing a character rig, essentially, into Omniverse, then rendered on another device, and streamed to here to a laptop, to an iPad. And if you see in the corner, there's somebody who's using a content creation application now adjusting the scene as well. So we have the combination of AR through the tablet, we have a desktop application, we have computer vision, all operating on the same scene. Here's another example of remote collaboration. We have people in Usense suits being digitized. Those poses are then published as part of USD, then rendered. We have a separate camera operator holding a tablet using ARKit. Again, that's being published in this open standard USD, going across to all of the connected people who are experiencing this scene. Here's an example of physics. Oops, sorry. Oh, here we go. There we go. Okay, so here's an example of physics in Omniverse. And what the physics simulator does is it basically looks at the world. It identifies the objects that are participating in the physical simulation, updates them, moves them around, publishes the altered USD, and that is then available to everybody who's trying to subscribe to the same virtual world. And we have somebody who's in VR, touching these objects, moving around. We have the ability to have simultaneous users then experience it in their favorite way, whether it's desktop or AR or VR. Just one further comment about the different layers. Each one of these layers that we talk about as part of the USD has its own URL. So in this character example, you can have a base mesh that you perhaps created in ZBrush. That could be one layer. You can add props to it. For example, you may choose to use 3D Studio Max. That's in another layer. A separate file that's shared through the Nucleus server. You can add additional capabilities of lighting in separate layers, materials in separate layers, all independently editable. And each one can be anywhere on the entire internet. So I want to just finish by asking people to join us in looking at USD, looking at its capabilities, extending it as much as possible, and helping us build out this vision of the open metaverse based on open standards and open protocols.